this module, we are going to discuss on theoretical concepts of operating system. The major learning objectives of this session is to know the concept of operating systems and their types, and also to acquire the basic knowledge of operating system and its functions. This module has the following agenda. It starts with an overview of an operating system, followed by hardware and software, then basic concepts, uses of an operating system, type of an operating system, and finally with key features. Coming to the overview of an operating system, this is the first software which gets loaded into the computer memory and makes the computer operational. It controls hardware components such as mouse, hard disk, keyboard, printer and display unit, etc. It also controls all the software which are installed in the system. I would like to explain the two terms hardware and software before going into detail. As far as hardware is concerned, it is an entity which we could touch and feel. Example, monitor, keyboard, mouse and hard disk, etc. Coming to the software, software is the set of instructions that perform specific tasks. It interacts basically with the hardware and produces the desired output. Software is classified into two types. One we call as an application software, other one we call as a system software. Application software is concerned, it is a set of programs to perform specific tasks. Example, I could say a Word, MS Word and VLC player. MS Word is used to prepare a document. VLC player is used to play a multimedia application. And system software is concerned, is a type of computer program that is designed to run the computer hardware and the application program. Example, operating system is the system software and other language processor which is used to translate a high-level language program into machine language program. I could say now, operating system is the system software which serves as an interface between the computer user and the computer hardware. It controls input, output and other peripheral devices such as disk drives, printers and other electronic gadgets. Its functions include memory management, process management, information management, device management, etc. Without this operating system, all these resources cannot be effectively managed. And this is the first program which gets loaded into the computer memory when we switch on the computer. That process is referred to as booting. Some of the popular operating systems are Windows, Unix, Linux. And the mobile devices, it uses Android and iOS as mobile operating systems. As a whole, operating system, it interacts with the hardware, application software and also provides a very good interface with the user. Now let me explain the uses of an operating system. The first one is extraction. In a computer, we could store a lot of information. Operating system will help us to extract the desired information in a desired format. Second one, interaction. As I mentioned earlier, it provides a very good user-friendly interface so that we can easily access with the hardware. Third one is booting. That means makes the computer operational. That is, operating system gets loaded into the primary memory when we switch on the computer. Fourth one, resource management. Some of the resources are computer primary memory, central processing unit, devices, information, otherwise we call as file. And these resources are effectively managed by the operating system. And the fourth one, security features. It provides a facility to create username and password so that many people, when they are operating in a single computer, they will be provided individually with a separate username and password. Not only that, and there is a provision for giving a restricted access to the file which we store in the computer. So these are the uses of an operating system. I could summarize: one is extraction, second one interaction, third one booting, fourth one resource management, and the fifth one is security aspects. Now let me explain the types of operating system. There are two types of operating system. One we call single user operating system, the other one is multi-user operating systems. In a single user operating system, only a single user is allowed to perform a task at a time. It is called as a single user and single task operating system. MS-DOS is an example of single user, single task operating system. In a multi-user operating system, it is used in computers and laptops, and many users, multiple users, they can share the common data and applications. Even they can communicate with each other. Windows, Linux and Unix are the example for multi-user operating system. So now we are going to see all the key features of an operating system, what we have discussed already in detail. They are file management, memory management, fault tolerance, process management, security management, and user interface. One of the key features is user interface. The user interface should enable the user to retain their expertise for a long time. That means the comments, the click they used to give should be rememberable. Second one, the user interface should also satisfy the customer based on their needs. It should be easily accessed. The user interface should also save the user's precious time. There should be a shortcut provided to access a particular file or to open up a particular application and so on. And the fourth one, so whenever you go for any product, aim of preparing a product or producing a product is to satisfy the customer. Similarly, the user interface is also to satisfy the customer. The user interface should reduce the errors. The interface should be designed in such a manner that people can perform what they desired without making mistakes. The next key feature is memory management. Memory here it means the random access memory. So operating system is used to keep track of which portion of the memory are currently occupied by the program and which are the portion which are not yet occupied, so that whenever a user want to execute a program, unallocated area in the memory could be allocated. Second one, determining which process and are part of processes and the data to be moved in and out of memory. Okay, so basically all these programs are saved in the hard disk. So whenever it is being executed, it will be loaded into the primary memory. Okay, so the process and data will be moved in and out of memory, in the sense some of the program, like when we save the program, it will be saved in the computer secondary memory. When we save a document, it will be saved in the secondary memory. When you open up the document in that, because every time we used to say that a random access memory is a volatile memory. When you switch off the computer, everything in the volatile memory get erased. So what we used to do, always we used to say, you save your program. What will happen? All these programs are being saved in the secondary memory. Okay. So whenever you open up a program, that will be loaded into the primary memory. That is what they mentioned here, determining which process are part of a process. Sometimes the entire process will not be loaded into the primary memory, and the portion of the process and the data to move in and out of memory, that is from the secondary to primary and primary to secondary. That is whenever there is no room to hold a new process in the primary memory, the unused process in the primary memory will be moved into the secondary memory. And third one, allocation and deallocation of memory blocks as needed by the program. So memory, there are so many blocks, like in a book we could say that there are so many pages. In a memory we used to say that so many blocks. Okay, whenever we are supposed to allocate a room or allocate something, and we used to follow some strategy. And so here this operating system, it follows some algorithm to allocate and deallocate memory blocks as needed by the program in main memory, that we call as the deallocation, we call as garbage collection. The next key feature is process management. When we execute a program, a process will be created. In a multitasking environment, there are several processes. They are competing to use the resources. So this process management, that will be taking care of that. So this one of the function of this process management is to create and delete process. Second one, when so many processes are created by a single program, inter-process communication and synchronization is needed. That is taken care by the process management. Third one, scheduling. Like when there are several processes, they are competing to use the computer processor, central processing unit. It will be following some scheduling algorithm that we are going to see in detail. There are collection of processes running in the computer system. They are categorized as system process and user process. System process in the sense those process will help us to run our process, user process. Like operating system itself create many process to handle user request. So that will be executed by system code, and user process will be executed by user code, and these two processes are concurrently running in the system. The most commonly used job scheduling algorithms are first in, first out, shortest job first, round robin, and based on priority. All these algorithms are mainly used to allocate the job, otherwise called process, to the processor when there are several processes competing to use the processor. The first algorithm is first in, first out scheduling algorithm. This algorithm is based on queuing theory. The person who enters the queue first will be processed first. Consider an example. In this queue, there are three processes waiting. One is A, B, C. In the queue, A is the first process, B is the second process, and C is the third process. So according to first in, first out scheduling, the process A gets processed first, followed by B, then C is processed. And you can also take an example by the time D arrives the system. So D is waiting in the queue, and that is the next process to be processed. So as of now, according to this example, the order of execution is A, B, C. D is waiting in a queue for to be executed. The next scheduling algorithm is shortest job first algorithm. This algorithm works on the principle based on the size. Again, an example. Here there are three processes A, B, C. The size of process A is 4 KB, B is 8 KB, and the C is 2 KB. Among these three processes, C is the shortest process, or otherwise we call as a job, and that will be chosen for execution first. And that gets completed. Then among A and B, A is the shortest job, that will be processed next. Then B will be selected for execution. So the order of execution is C, A, B. The next job scheduling algorithm is round robin scheduling algorithm, and this is designed especially for time sharing systems. Jobs, in turn called processor, are assigned the processor time in a circular fashion. Consider this example. Again, we have got three processes, and each process it needs their own time for processing. Now, process A it needs 4 microseconds, process B it needs 2 microseconds, and process C it needs 6 microseconds. So here we also assume that every time when a process gets the processor, it can use only 2 microsecond. Then again the next process will be chosen and the next process, and it will be served in a round robin method. So initially A will get the processor time only 2 microseconds, and it again come back to the queue. Then next process B, it gets the turn of the processor. It needs only 2 microseconds. So B process could be completed now. Now it is the turn for the process C. It needs 6 microseconds, but processor can assign only 2 microseconds. So the remaining for to make use of the remaining 4 microseconds, again it comes back to the queue. Now it is again the turn for A process. It needs only 2 microseconds now. So it gets the processor turn and completes its process. Now C, it is the turn for C process to make use of the processor, and 2 microseconds will be again it comes back to the queue. Therefore the remaining 2 microseconds, once again the processor will take this process that will be completed. So the order of execution is first process A 2 microseconds, process B 2 microseconds, C 2 microseconds, again A will get a 2 microsecond, and so on. The next scheduling algorithm is based on priority, in which every process will be assigned a priority. So in this example is concerned, process C gets the highest priority, process A gets the next priority, and process B gets the third priority. So a processor from the queue, it takes the highest priority job, that is process C. Then that will be completed first. After that, comparing A and B, A has the highest priority. So A process will be taken for processing and that will be completed. Next, only one process in the queue that will get processed. So the order of execution is C, A, B. The next key feature of an operating system is security management. The major challenge in computer and software industry is to protect users' legitimate data from hackers. The operating system, which provides three levels of security to the users. They are file access level. So in file access level, in order to access the file created by other users, one should get permission, access permission. Permission can either be granted by the creator of the file or by the administrator. Second one, system level. And it is offered by providing a separate username and password in case of multi-user environment. So every user, they will be provided with their own username and password. So they will be accessing only the intended data allocated for them. And the third one is network security. It is an indefinable one. So people from all over the world, they provide such a security. And all these three levels of security features are supported in the operating system. The next key feature of an operating system is file management. File management is an important function of OS which handles the data storage techniques. So operating system manages all the files, folders and directory on a computer. Here it uses a table called file allocation table, which stores the general information about the files like file name, type of the file, size of the file, starting address, and access mode. So the file manager of an operating system helps us to create, edit, copy, allocate memory to the file, and also it updates the relevant information in a file allocation table. There are few other file management techniques available. They are next generation file system NTFS and ext2 in Linux operating system. Other features of an operating system are multiprocessing, in which we have got more than one processor for processing a single job. Processing takes place in parallel, known as parallel processing. And this feature is used for high speed execution, which increases the power of computing. The next feature is time sharing, and this is one of the feature of an operating system. It allows execution of multiple tasks or processes concurrently. For each task, fixed time is allocated. And that is only one processor, many processes. And this division of time is called time sharing. The processor switches rapidly between all the processes after a time is elapsed or the process is computed, as we have seen in round robin scheduling. The next feature is distributed operating system, which is used to access shared data and file that reside in any machine around the world using the feature of internet or intranet. The user can access as if it is available in their own system. The advantages of distributed operating systems are the user at one location can make use of the resources available at another location over the network. So many computer resources can be shared and added easily in the network that could be made accessible to all the people connected in the network. And also it improves the interaction with the customer and clients. And it reduces the load on the host computer because the resources are distributed. And these are the advantages of distributed operating systems. The prominent operating system available are Unix, Microsoft Windows, Linux, iOS, Android, and so on. So to conclude, in this module, we have discussed about the basic concepts and the knowledge about an operating system, types of operating system like single user and multi-user operating systems, and uses of an operating system, key features of an operating system, and particularly we have studied that process scheduling algorithms, and hope you have enjoyed the session. Thank you.